Hello everybody and welcome back to my YouTube channel. Today I will show you how to do a land use land cover classification using machine learning algorithm, specifically support vector machine in QGIS software. All of us know about the importance of land use land cover classification in remote sensing community. This option in QGIS recently is available to do a land use land cover classification using machine learning algorithms. In order to do this, I'm going to use a Sentinel-2 data. So if you like these types of video, please like the video and also subscribe to my channel in order to be notified regarding the future videos from the channel. Okay, let's start. First of all, I'm gonna download Sentinel-2 data from Copernicus website. To do this, I'm gonna go to my browser, search for copernicus.eu that I will provide the link in the caption of this video. It's required to have an account if you want to download data from this website. If you don't know how to do this, I'm gonna give you a link of video that it's available in this channel, how to download Sentinel-2 data from Copernicus website. Since I have already an account, I'm gonna go to login. I provide my email and also password and click on login. You see that I'm successfully logged into Copernicus website. In order to download an image for my study area, first of all, I'm defining my study area. For example, this part. In order to define a study area, it's easy to come here from create an area of interest, click on that and select and draw a rectangle. Very good. Right now, one click and draw an area that you are interested, and that's it. Another click and end your dragging. Okay, right now I'm gonna back to left part of the website. From search, you can see different options here. Click on Sentinel-2 level 1C. The difference between these two levels is that some atmospheric correction has been done on level 2A. However, I'm going to use level 1C. And also here you can define your time range. For example, I want from 1st of June until the end of July 2025. Click on search. It's gonna take a while in order to load all available Sentinel-2 data for this study area. Okay, the time it's completed. From here you can see different image. Try to find an image without cloud cover. For example, this one. In order to check, you can click on product information. Since I have not seen any cloud cover here, I'm gonna download this one. Here we have a workflow. As I said before, the same thing. As I said before, I'm gonna click on Sentinel-2 level C and click on download. Here you can see the download procedure. It's gonna take a while in order to be downloaded. Very good. You can see it's downloaded successfully. Right now you have a new tab like this that is asking you to define the area, the folder that you want to save your data. For example, I'm going to go to desktop, create a new folder. Since I'm going to classify land use land cover, I define it. In the next step, another folder, data, and click on save. Okay, right now we have successfully downloaded Sentinel-2 data required for land use land cover classification using support vector machine in QGIS environment. Right now I'm gonna go to my folder. Since it's a zip file, I need to extract it. Click on the right click on the file, render, extract. Very good. Right now I have my Sentinel-2 data. Open your QGIS. If you don't have QGIS software, I will provide a link showing you how to download and how to install this software. In order to classify land use land cover using QGIS, you need this plugin SCP. If you don't have this plugin, it's easy to come to plugin from manage and install plugins. From search for semi. Here you have to put on all and search for semi-automatic classification plugin. Since I have downloaded and also installed this plugin, you can see it's checked. If you don't have it, it's easy to click on this. From here you will have an install plugin. You can click on that and it's gonna take a while in order to be installed. It's easy to do this. Okay, very good. Right now I have my plugin here. It's gonna come to here. If you don't have like this one, it's easy to click on that, for example, like this, and you can open your plugin. Okay, we have different options here that I'm gonna explain you one by one as we go further. For example, band set is one of the most important part. In order to call your data that here is Sentinel-2, it's easy to use open a file, or if you have already opened your data, it's easy to use this option add bands loaded in QGIS. Since I haven't uploaded into my QGIS, I'm going to use this one. Open a file, go to the folder that you saved your data, image. I'm going to select all Sentinel-2 data bands. For example, we have 12 bands here. It's a 13 bands, but it's written like this. Select all of them and import it into my QGIS environment. Right now, I have set a band. I have a band set, a collection of bands. Okay, if you want to move your highlighted bands up and down, you can use these options. If you want to sort your bands, you can use these options. If you want to delete one band or all of them, you can use. If you want to reset your band set, you can use these options to here. Also, we have something import bands from text file, and if you want to export one bands to text file, you can use these options. Also, here we have wavelengths related to each sensor. For example, as you can see, we have a list of sensors: Landsat 9, Sentinel-2, MODIS, GeoEye, and etc. Depends on your image that you are using, you can put on one of them. And also wavelength units, if you are interested, you can put on them, and also the data of the image that you have downloaded and you want to work with it. Right now, from wavelengths, I'm gonna put on a Sentinel-2 since I'm gonna work with this data. I don't want to define them, and I will leave them in default. The first things that I'm going to do is create a virtual raster. To do this, I check this one. If you want to create a raster of band set, you can do this. and the other options are also available here. As you can see here, we have a band set table that is related to all the bands here. In order to do this, I'm gonna select all the bands and also check you have to create a virtual raster of bands. Right now, click on Run. After clicking on Run, you have to select the folder that these data are going to be exported and also saved there. For this purpose, I'm gonna go again to the creative folder here, create another folder, this time band set. Okay, as you can see, it's selected right now. Select on that. Okay, very good. It's down. As you can see, we don't have any things to be visualized right now. From RGB in your QGIS environment, you can select one of these combinations. Okay, as you can see, we have a virtual band set that we created before. Why I created this is that because I'm gonna collect some training data for my land use land cover classification. And also you can check and change based on your interest. For example, I'm gonna use false color composite. 8 is a near infrared, 4 is a red band, sorry, 4 and 3 is a green band. Okay, click on that. We have a false color composite. Okay, very good. Right now, I'm gonna give you a list of composite names. If you are interested, you can use these options specifically for Sentinel-2, for example, for detecting agricultural land. This composite is going to be valuable also for detecting land and water. You can use this composite, and the others options also available here. Okay, very good. Right now, the second step in land use land cover classification is to collecting some training data. From SCP, we have a training input. Click on that. Okay, when you do it, you have open a training input. If you have already a text file that you created some training data, it's easy to click on that, and you can see here you can go to the folder and open it. Since I don't have these options, I'm gonna create by myself. In order to do this, create a new training import. Okay, as you can see, it's required to create a new folder. For this one, training data, I name it. Inside that we have, for example, I'm gonna say land use. Very good. When it's done, now you can create your training data. Here we have different options that I'm gonna show you later. However, the most important point is here. For example, macro class ID, and also we have a macro class name, class ID, and also class name. What does it mean? For example, we have a macro class ID 1. They are automatically changed, but you have to do it sometimes by yourself. For example, as the macro class, first I'm gonna start with water bodies, for example. Water body. It is my macro class name. As the class 1 for class name, we have, for example, dam. As you can see, we have number one for macro class ID and for class ID. You have to change this by yourself, but this one is going to be automatically. Okay, right now I have this option. Right now I'm gonna back here in order to create some training data. In order to create some training data, it's easy to use create a ROI polygon. Click on that. As you can see from your cursor, it's ready to collect training data. Go to the place that you know they are them. In order to collect training data on your keyboard, it's necessary to press Control every time. Then, with your mouse, start and collect the data that you are interested. Try to collect pure training data. When you are down, it's easy to right click and you can see like this, it's selected. Right now I'm gonna go to the next one. Here we have, again, I have to press Control on my keyboard, don't forget this. Okay, very good. If you do not press Control on your keyboard, for example, I'm not pressing that. If I click in another place and do some collection, you can see when I do it for the next one, the first one is going to be disappeared. In order to do this, it's better always to press Control on your keyboard. This is the first one because we didn't use Control. It's disappeared and we need to do it again. Okay, very good. This is for dam. Haven't seen any dam here. Okay, right now I'm gonna, in order to create this class, it's easy to come here, SCP, and click on Save Temporary ROE to Training Input. Click on that. It's gonna take a while, as you can see from here. Okay, very good. Right now I have my macro class and also class. You can change the color from here, double click. For example, for macro class, I'm gonna define this color as the dam and also this color. Very good. I'm gonna go to the next one since I don't have any water body. I'm gonna go to this time to vegetation. Okay, very good. As I said before, this one is going to be automatically changed. However, you can change this one if you are changing your macro class ID. For example, if I had another water body, for example, a river, uh, I don't need to change this one. For example, I think here we have, yeah, we have rivers. For example, I'm going to show you a river. Again, backing to your image. It's a small one, however, again from create ROI. This is for water. Okay, very good. This is also for river. Again, in order to create temporary. Alright, change the color. This one is suitable. Right now I'm gonna go to the next macro class, this time 2, and this time I'm changing to vegetation. And as the class name, I'm gonna give it agriculture. Back to create ROI, press Control and continue to collect your training data. You can specify them, however, I'm gonna do this as soon as possible because I don't want the video to be so long. And also the most important thing about collecting data is that try to collect data from every part of the image. I mean, the distribution should be wisely and also in a balanced way. Okay, very good. This is also for agriculture. Again, create on temporary ROI. If you want, you can change the color. For example, for macro class, I'm gonna give that one. For agricultural lands, this one is okay. If you have another vegetation class, you can add. However, I'm gonna go to the next one. This time changing macro class ID to land as the first class of land. For example, bar is okay. Again, back to your image, click on create ROI, press Control, collect your data. If you want to have a precise land use land cover classification, you can increase the number of your classes. This is kind of tutorial that I'm going to show you how to do this. Again, create temporary ROI as training input, click on that. For example, for vegetation, you can add, for example, garden, cultivate lands, grasslands, and etc. Again, I'm gonna change the color of land as macro class, as the bar land also too. For the last class, change the macro class to 4. This time for a built uh, area. The first one is gonna be city. You can change to settlement if you're interested, but I prefer city. From create ROI, go to the cities, define your ROI. Don't forget to press Control on your keyboard. Okay, very good. I think it's enough. Again, create temporary ROI. Okay, very good. Right now, it's time to do a land use land cover classification after collecting training data. Back to the semi-automatic classification plugins. We have different options here. In order to do a classification, it's easy to come to band processing. In classification sections, we have different options. For example, this one is most important. We have a selected input band set. It's asking about the band set that you have provided before. Since we have one band set, I'm gonna select this one. If you have the second one, you can put, and you want to work based on that band set, you can change to 2. Otherwise, you can leave it in default. I will leave this also in default. It's asking me about you want to use training macro class ID or class ID. It's better to use this one since I'm going to use this one. We have different options of classification, classify here, maximum likelihood, also machine learning algorithms here. Since I said before, I'm gonna use support vector emissions this time. Here we have different options. As you can see, for example, for the regularization parameter C, depends on your preferences. For example, you can increase or decrease this one. I'm gonna give you some explanation about different parts of this, and also here we have a different kernels. The default is RBF. However, if you want to use the other kernels, support vector machines provides linear, polynomial, RBF, sigmoids. Depends on your preferences and also application. You can choose one of them. For example, RBF is well known for complex classification, complex problem inside the classification. It's very good for this. And also sigmoid for neural network application. If you want, you can use that one. Polynomial, as I said before, it's very good for polynomial relationship and also linear relationship. It's can be used with a linear one. As the gamma, we have a scale here, lower gamma, wider influence, and it's gonna result smoother results. Higher one, uh, higher gamma, also less influence on the result. It's gonna increase the risk of overfitting. Then you have to pay attention in order to select an appropriate number for this one. Okay, very good. Right now I'm gonna go to the cross validation. As you can see here, we have, if I check that, It's gonna give me these options to avoid overfitting. I want to do this. In order to do this, I'm gonna check this one. Balanced class weight gives all classes equal weights that is computed inversely proportional to class frequency in the training data. Then if you want, you can check that one too. Otherwise, you can leave it in default. I'm gonna use that one. The third one is the fourth one from here. The third one, find best estimator with steps. Again, if you want, you can check it, but it's talking about find best estimators with the defined number of steps. More steps means slower processing, and lower steps means less processing. And also, if you want, you can click this one, check this one if you are interested. Otherwise, you can leave them in default. In order to get some information regarding this classifier, use helps here. For example, support vector machine, click on that, and you can see different information here for different classifiers. The last one is support vector machine. You have to scroll down and you can see it here. For example, as I said before, we have information regarding different options in this classifier. Okay, I'm gonna back, and also I have some information regarding the kernels that I said before. For example, we are using RBF here, that it's very good for Sentinel-2. And if you are interested, the other classification, for example, basic land cover classification, you can use linear, or for urban areas for crop typing mappings, you can change to polynomial. I'm sorry. Okay, since I give you some information regarding different parts of this classification, right now I checked everything, and I'm gonna click on run, define an output folder, for example, also a name as LULC, save. It's gonna take a while in order to classify our land use land cover. Since the study area is big, it's a tile of image. Okay, very good. When you're down, it's gonna give you a classification like this. From here you can see. As you can see, we reached the classification result. We need to have much more classes. However, I show you how to do this. And one thing about why I used a tile of image, this is the things that I tried a lot, but I couldn't fix it. I tried to extract by mask one part of the image. However, or every time I had error. You guys, if you find a new way in order to fix this problem, please leave in comments your response and also your suggestion that I can use it. However, personally, I couldn't find a way in order to use one part of image. Because of this, I prefer to use a tile of image that, of course, it's going to increase the time of processing. Okay, very good. I hope the content of this video will be useful for you. Thank you very much for your attention.